today's session is about performance key patterns and anti-patterns in Dynamics 365 for finance and operations. Let me move on to the next one. So first of all, the session overview, and let me give you a little bit of background. So within the solution architect team, we're doing often performance reviews. And as a result of these performance reviews, we often see the same issues popping up again. So out of this, we created some patterns. Some are positive patterns, which we have seen in project teams implement successfully. But we also see over and over again patterns, which we call here anti-patterns, that can lead to serious performance degradation. So in this session, we try to highlight the most important ones. Of course, there are more than the one that we cover in this session, but these are the ones which were popping up the most when doing these reviews. So this for a little bit of the background. So I will jump straight into the different patterns, but this slide gives the short overview. I will not go in one by one. I will go now through each of them in more detail. So both the patterns and the anti-patterns are a little bit mixed up through this presentation. The first one is regarding the data management framework, the DMF, for bulk imports and exports. What we see here is that a lot of times it's used in the correct way, but a lot of times also some specific tuning actions are forgotten. So for example, that you can use delta loading or the incremental push after full push, that you can enable set-based processing for certain entities, of course, if they are developed in a way that they support it, that you can use parallelism, for example, for mass imports scenarios, that you also have to think about other things like, for example, disable unnecessary validations or configuration keys, which can lead to an overhead in the data import-export framework. Number sequence pre-allocation, I will come back to this later in a separate pattern, but it's important for the non-continuous number sequences that are consumed a lot, that you set some pre-allocation to maximum use the caching possibilities within Dynamics 365 for finance and operations. And last but not least, the cleaning up of staging tables. We still see a lot of times for recurring integration scenarios that staging tables are not cleaned up and that these tables are just increasing in size and also have a big influence on the performance. A few visualizations about this topic. So if you go into Dynamics 365 for finance and operations and you click on the data management workspace and you go to the data entities, you will notice that for certain entities, you have specific settings. And the two settings I would like to highlight here is, first of all, the set-based processing, to be able to set-based operations at the database level. And again, we also go more deeper into set-based in a different pattern later in this presentation. And the other thing I want to highlight is to enable change tracking, which you can do with several options at the entity level as well, to be able to use, for example, an incremental push. The other place within data management is in the framework parameters, where if you go then in the framework parameters to the entity settings and you go to configure entity execution parameters, that you can set up for a certain entity parameters like the import threshold record count and the import task count. And this will enable you to do some parallelism within the import. For example, with 4 threads available and 4 cores available, for example, in the AOS backend, and having import threshold record count to 1000, you can then split your workload in bunches of 1000 records and they can be processed then in parallel. Again, we see a lot of times customers coming back to us or partners during the project phase where they say that the DMF is not performing well. And when we go into more detail, we can see a lot of times that we're not hitting any threshold at the AOS or SQL level, but simply the workload is not tuned to maximize the performance. The second pattern is related to this. This is actually to not misuse OData, because we just mentioned that for large bulk import export, we advise to use the data management framework. what we see a lot of times in a lot of performance escalations is that OData is used for very large volumes, which can also lead to performance issues. So we have sometimes large interfaces that are built on top of OData, which is probably already an incorrect design at the early stage of the project, which can lead to very slow processing. We want to stress here that OData is designed normally for limited number of lines per hour for limit volumes and primarily for real-time calls. One example mentioned here, and I will come back to this in a second slide, about the use of OData connector for Power BI, which hit directly the performance of the AOS and the database, which also lead to performance issues. So instead, better use than the entity store or the BYOD solution. Let me visualize this a little bit more. So this is a comparison between OData and DMF for bulk import exports, where you can see at the top where you use OData, you go row by row, you go synchronously, you use no batch bundling, no sequencing can be used, and it's normally for smaller volumes, like as an ID, it's 1,000 to 5,000 lines. Of course, this is just a rough estimate, but it's for the lower volume integration scenarios, which should be real time and where you cannot enable any of the parallelism. The other at the bottom is DMF, where you can go to much larger volumes, as an estimate here, 200,000-300,000 lines per hour, of course, depending on the workload, how you design your entities, if you use parallelism, if you use set-based operations, this can be really highly scalable. This is a visualization about my comment, which I just mentioned about the OData connector for Power BI reports, which hits directly the AOS and then also the AXDB, the transactional DB, which could lead for larger volumes of data to performance issues. So instead we recommend to use the entity store and then the embedded Power BI, and just do a direct query on this database. Alternatively, you could also use the BYOD solution and run your Power BI reporting from this other DB in your own of an external Azure subscription. Then about tuning the batch framework, this is what we see also a lot, that there is no overview in the projects about which batches are running. And this is not only batch, it could also be other integration processes, heavy integration processes are running at which time in a 24-hour time schedule, for example. So we always advise to create such a 24-hour timetable and to get an overview of what is running when. It's very important so you can spread the workloads, and this should already be done very early stage, of course. And when you do your performance testing throughout the project lifecycle, you then can already take this into account and set up such performance benchmark make using of this timetable. So you define different batch groups, and this is also a lot of times not done. And the idea of different batch groups is then that you can assign specific batch servers to each of these batch groups. This will help you to balance the load across your AOS servers. How you do this in system administration, set up batch groups. You can add additional batch groups, and remember that the empty batch group, which is available out of the box, should be reserved for system batch jobs only. And then from there, you assign batch jobs then to the appropriate batch group. Sounds simple. It's there already also from the previous releases for a very long time, probably since the beginning of the AX time. But still we see a lot of times that it's not tuned correctly, the batch framework. On top of that, in platform update 21, we added an additional feature which we call active periods, where you can assign batch jobs to. And the whole idea about active periods is that, for example, you can have batch jobs that need a high recurrence, but maybe only during business hours, maybe not during lunch breaks, or maybe just during lunch breaks. So for this, you create different active periods. Like in the example here, I have, for example, a default period and then an active period break, an active period non-business hours. And then what you do then is after you have defined the effective periods for each batch job, you can assign it then to appropriate active period. Just again, helps you to balance the load and to not necessarily process batches that are not needed at that specific moment of the day. The last thing about tuning the batch framework is a setting which you can find under System Administration, Setup, and Server Configuration, which is the maximum batch threads out of the box when you have an AOS, which is you have several AOSs in your production environment, but each AOS is normally meant to serve both the batch workload and the interactive user workload. So you always have to take into account that if you stress an AOS server completely with batch workload, it probably will hurt the performance of the user interaction. So by this maximum batch threads, you in a way limit the number of threads that the batch can utilize on a specific batch server. By default, it's on 4, and we see it a lot of times it's not tuned. Of course, how to tune it, it's about testing. If you don't do performance testing prior to your go live, then it's really hard to say what should be the ideal setting here. But if you tune it up front, you probably can utilize the maximum performance out of an AOS box by just increasing this number or decreasing depending on the workload. So it's an important setting to take into account. The other thing I would like to highlight here are some of the techniques that you can use to run your batches in parallel. And this is, of course, doing design and then development phase. These are blog articles. They can also apply for previous releases, so they're not very recent, but the same principles still apply. You could still, for your batch workload, you could still use different techniques to use parallelism, like batch bundling, individual task modeling, or top picking. And then there is a comparison of the 3 techniques you can find in these blog articles. The next one is do have proper indexes in place. Again, very obvious, everybody would say, of course, but still we see a lot of times it's not done. We still see a lot of queries, custom queries, sometimes also standard queries without a proper index in place. And this example is a very simple example here, which highlights one that doesn't have a correct index and the other one has an index. And the upper part is just scanning all rows. And the bottom part, it can immediately go and do a seek to the qualifying rows. Also make sure as a comment, additional comment to this, to have a clustered index on each of the tables. Because tables without a clustered index, we call them heaps. There is no physical sorting on a heap. And as a practical example, my colleague gave once, and I liked it a lot, is about a library where you just throw in the books all at one big pile, and then you come in and you have to find your favorite book. Well, good luck. You have to just scan the entire pile until you probably find your favorite book. So it's really important to have the indexes in place. You can create indexes directly, and we come back to it later in the presentation for some other topic through LCS. We have some features there to create an index directly to the database backend as sort of a immediate mitigation, short-term mitigation. But it's still very important that all these indexes that are created in the end will be part of your code base. So if you start early with performance testing, then during your development, different development life cycles, you can just add these indexes to your code base. And when you do the retesting, you can see the result. Next one is use of number sequence pre-allocation. I already highlighted with the DMF. It's a general topic. It's again there since the early days of AX, but it's worth to remind all of us because we still see that a lot of times number sequences are not tuned, which result in high number of database lookup. Can be even log escalations to certain tables like the number sequence table. You do not make use of all the AOS caching capabilities, and of course you have a reduced performance. Of course, pre-allocation can only be used for the non-continuous number sequences. So also as a first exercise, probably it's to differentiate between which number sequences really need to be continuous from a business perspective. And for the other ones, they should be non-continuous, and then you could use the pre-allocation option. Just put here an advice, which could be an initial advice about what the setting could be. Again, this should be tested. It's not an official recommendation here. It's more like a rule of thumb that I added this recommendation here on what should be a good initial setting for a certain number sequence, depending on how many numbers are consumed. And these numbers are per business day here. Where you do this is under organization administration, number sequence. And then for a certain number sequence, which is on non-continuous, you could then go to the bottom part, performance, and you can activate pre-allocation, set the quantity of here, for example, it's set to 10, and that's it. The next one is do not run expensive record by record operations. We also in standard, but also customized code, we really advise to use set-based operations wherever it's possible. It was always important, I think, with Dynamics 365 for finance operation in the cloud, where the AOS and the SQL are, of course, within the same data center, but still the latency between the AOS and the SQL will be from 1 up to several milliseconds. So you can imagine that if you are going row by row versus set-based, it's a huge difference. We sometimes also get examples where the one box is faster than a multi-box or tier 2+ environments. Specifically in workloads where you work row by row and you have this latency each time added in this case, to the trace then when you compare. Of course, it could be that certain workloads are then a little slower on the multi-box than on the one box. The whole idea is here to go set-based as much as possible. On the left side, you see an example where we just do an update of 1,000 rows for a table, and we just go row by row. On the right side, we go set-based. And the result you can immediately see in the trace, because on the left side, you can see it's highlighted in yellow. It's 1,000 times I do a DB call. It results in 332 milliseconds of inclusive time on the database level. Versus on the right side, you can see it's just a single update, a set-based operation, which updates all these 1,000 rows in one shot, and it only takes like 6.67 milliseconds. So a huge difference. I already mentioned a few times data caching, use of data caching. Again, data caching is in since the early days. The principles are still quite similar than they were in the past. There may be a few minor changes. So, but we still see that data caching is not always used correctly because maybe there are simply at development time some properties not set correctly by the developer, and then the whole data caching cannot be used. For example, we see still a lot of tables which are created without a cache lookup property. If you do not set at the table level a cache lookup property, you cannot use the data caching correctly for that table. The next thing, after you set up the cache lookup property, you have to verify that at least one unique index exists, so one index with allow duplicate set to no. And then the property primary index has to be set then to one of this unique, or if they're multiple, at least to one of the unique indexes. These are some settings that has to be done correct at the development level in order to the caching to be used correctly. There is an example, which is just like a generic example. It's not code which is ready to go in a production system, just to visualize it. At the top, we are not using caching. So the cust table, even that it had the properties all set, we in X++ coding or in the coding, we set disable cache to true. So to not use the cache, and then we are just looping through row by row, more than 65,000 times, and we select something from the cust table. Versus at the bottom, we make use of the caching, and we do then exactly the same code as we did at the top. The difference is if you do the tracing, you can see that at the top we exactly go 65,000 times plus 65,000 times to the database backend So more than 65,000 round trips to the database. If you add the latency to that between AOS and SQL, so on the multi-boxes could be even higher on the tier 2 plus, but it's like here 13 seconds, so more than 13,000 milliseconds. Versus at the bottom in green, you can see that the same logic to be executed, just when caching is applied, it just has to be done. Only one single database call has to be done for 258 milliseconds. So it's a huge difference. Another one is to use generic methods wisely. For example, in this example, it's the find method. So this is similar code than you saw before, but what we do here is we make use of the cache in both cases. But of course, what we do here is we make use of the find method, and this we sometimes see in code. It's not that simple and that obvious as in this example, but where you have, for example, during development phase that developer A of developer person 1 needs to have field A and B, and then later on, for this functionality, we also need to have field C. So we're just adding different find methods, like here is A, B, C, and D. And this can cause an overhead. So versus the other one where we just do a single find method and then just assign the variables. There's one comment to this, and we could go as an alternative solution. You could also use a query with a field list, which is a comment made at the bottom part here in the code. If you compare here the traces, then you can see that when you use not using generic methods wisely, it's around 7 seconds versus 1.6 seconds on castable find methods when we are using them in a way wisely. Of course, we could say this is not a huge difference, but again, this is just one simple example. If you have such examples throughout your whole code base at several occasions, then yeah, of course, it could lead to a huge difference in the overall performance. Next one is about cleanup routines. A lot of these cleanup routines are not new. Some of them maybe are, but most of them, they should be well known by all partners and also by most of the customers. A few important ones that I highlight here is batch history tables. We see a lot of them, a lot of installations of a lot of Dynamics 365 for finance operations live customers that do not regularly clean up these history tables. I got a suggestion, I think, during the bootcamp. Yeah, why would we not do the other way around? Maybe by not logging it by default and just ask customer or project team to activate it if they would like to have a history. That's not the case today. So there is by default history logged, and then it has to be cleaned up. And of course, we have a tool which is called Optimization Advisor. And we did a tech talk regarding tools just before the new year. So if you're interested in this, just you can get it from Infopedia. So I'm not going into tools into this session, but Optimization Advisor will help you, for example, to schedule some of these regular cleanup activities. And one which is already in the batch in this Optimization Advisor today is a check on batch history tables. The other one is on the notification tables, alerts, event inbox data, where the recommendation is, of course, if you don't use alerts, then it's better just to disable the batch, correct? That it doesn't fill up these tables when you don't need the data. Why would you fill it up? But if you need it, you also need to implement some cleanup, a regular cleanup. One comment to this about cleanup, I wrote a blog article which is mentioned at the bottom of this slide, which is not perfect yet. Probably that's why this also a blog. It will be updated in the future because I was asked to add a frequency column or column with advice how often you should do this, because it's also not a message that you would run these cleanup jobs like every hour, correct? This could also lead to another performance issue. So the whole idea is that you do this on a regular basis. It could be different from customer to customer installation, how often you have to do it, but you have to keep in mind that when you do it is also better during a maintenance window, correct? And not during peak hours of your business. DMF staging tables, I already mentioned, can be done from the data management workspace and then the staging cleanup tile. And then you have specific cleanup routines for journal cleanup routines, which I mentioned here. And then the next 2 slides, there are some specific ones related to warehouse management and also to inventory and warehouse management. Again, first advice is to read the blog post article, and if you have any specific actions about how often you should run it or still have some doubts, then reach out to us or to your responsible solution architect for a specific project or log a support ticket. The other one that we have seen a lot during the past months is that we had performance issues related to refresh of aggregated measurements. And the advice is here that when you're not using certain aggregate measurements within your Power BI reports, then they don't have to be refreshed, correct? If you don't use the data, why should you process it? And the whole advice here that we give is that you try to split aggregate measurements into categories like, okay, this one I don't need, so they don't have to be processed. Some of them maybe I would like to have updated frequently, like hourly, so this is one bucket. And the other one could be maybe only need to have the data refreshed daily. That could be another bucket. So in a way you have, the whole idea is that you split them up. Then you could cancel, the advice is to cancel the current scheduled deploy measurements batch job. And then to recreate the batch job, you can just go to System Administration, Setup, Entity Store, and then you select the measures that you would like to have, for example, in the first bucket of the frequently updated ones. And you click Refresh. To start a new batch job will then done instantaneously. And then you can set the recurrence to desired frequency. So this is the suggestion, and definitely when you create multiple batches, make sure that you are not putting the same measures in multiple batches, which we also have seen at some customers. This is leading even to a bigger performance issue. Then stay current on hotfixes. Hopefully you probably know all by now that by the end of April 2019, when we are hopefully all running, most of us were running in one same version, run one initiative. This will become hopefully less and less an issue going forward. But what we have today is that each and every customer is running in a sort of a different code base, both on the X++ or on the binary updates. Some of them are really behind and running on a really outdated platform. Some of them did not install critical X++ updates. So we see all of these examples. And of course, when you're talking about performance, this could also be an area which you could have, which you definitely should investigate to have some quick wins sometimes. So hotfixes so for example, the one that we really would recommend today would be the critical X++ updates, and also together with always be on the latest binary. Staying on current on hotfixes will limit the risk that you're facing, like standard bugs, crashes, performance issues, of maybe, it's another topic, but that you get a last minute notice for missing extension points. You can still see in the older environments that we have these 4 tiles, which are sometimes, a lot of times very confusing for customers. So going forward, as of 8.1, we only have like a single update tile. Then there is execute regular index maintenance. So about index maintenance, I'm not going to explain here in this session what index fragmentation is. I assume that you all are aware of this. And if you look in the old days when we held old storage technologies, then the impact would be bigger than it is today. But still, what we have seen is that for some specific indexes and for some workload types, that index fragmentation can still be very impactful.
Of course, you could say then, okay, Microsoft is responsible for the infrastructure, but also for the platform, the standard application. Why would we not take care of this whole index rebuild in the back end and the background, and not disturb the customer with this additional task? But the thing is that the current limitations we have in SQL Azure, that it's sometimes impossible to do a rebuild of indexes without impacting critical workloads. So with other words, it should be done, some of these index rebuilds and maintenance during off-peak hours and during maintenance windows. So for this, of course, you need to know the business and it has to be scheduled. So what we have available today, it will look different in the future when Azure SQL will give us more possibilities, but today there are actually two options. The first option is doing index maintenance in LCS using SQL Insights. This is not meant to do regular index maintenance. This tool is not meant for this. It's more when you are in a troubleshooting scenario, I would say, and I also put a note here. When you query, for example, if your query has been identified with a lot of I/O, and you have a proper index in place, and you have done all this analysis, but you think that, okay, let's check the fragmentation for this index. So then you could use queries get fragmentation details in LCS, and I have a few screenshots going in the next slides. So that could give you an overview of the index fragmentation, and then you could do an action in LCS to rebuild that index. But that's self-service, you cannot schedule it, and it's rebuilding the index one by one. So what you probably would like to use as a regular index maintenance is a system batch job, which we introduced in PU22+, which has scheduling capabilities, and you could schedule this during off-business hours at a rhythm that is needed for that specific environment. And that can be different from customer to customer. And there is also specific parameter settings you have to be aware of. So let's go to a little bit more detail here. So the first one I talked about was LCS in LCS, so in SQL Insights. If you go to the query section, you have a list of queries. You have there the get fragmentation details. And in there, you can then search for a specific index, and then you could get some details about what is the current fragmentation percentage, for example, and the number of records in that table. Once you think, okay, this should be like a good mitigation, then you could go to the Action tab, and you could select Rebuild Index, and then you give a reason, and then you could rebuild a specific index through LCS. I want to make you aware that all these changes or everything, all the actions actually that you're doing, that there is a trace of it. So if you go on the environment details, environment change history, you can see, for example, that on this environment that I yesterday rebuilt an index, and you get the details on the right side. So you always have a trace of who did what on a specific environment. The other one is the system batch jobs under system administration. So this is not an LCS. This is just in Dynamics 365 for finance operations. We have under system administration inquiries, we have a batch job, which is called, you can see here, the database index rebuild system job. And you can find it there, and you should tune it, of course, because in this environment, for example, with the screenshot below, it runs daily at 3 a.m. This is just like a demo environment. There is not much to do, so the start and end times are almost the same. But in reality, this is of course different on a production system. But this is one thing you have to schedule, correct? You have to know when you would like to run this and how frequently you would like to run this. And when this is run at least once, you can go to system administration inquiries database SQL index fragmentation details. Then you can see, for example, here I highlighted for some of the batch tables, some of the indexes in batch shop and batch table, where you can see then the fragmentation before and after a certain defragmentation run. And normally when there are less fragments, then the number of pages should also go down, which is then less pages to retrieve when you do certain select based on that index. And the whole idea is to get a better performance, correct?
make you aware of a few of parameters which are important for this system batch job, which you can find under System Administration Setup System Job Parameters. So here you can see in SQL Index Defragmentation tab, where you have actually 3 parameters. One is the overall execution time, which is in minutes, which is on 120, which is 2 hours. So if you have a larger maintenance window, or you see that the index maintenance job did not finish and could not do all the necessary index maintenance in the desired time frame, maybe you have to change this value. Also, the number of indexes that it will rebuild is a parameter here, and the DTU threshold. DTU is how busy the SQL server is. It's a combination of different measurements on the SQL Server backend, and you want to keep the DTU under control, right? So the DTU threshold here is put on 50, but during a maintenance window, yeah, you might also decide to higher this up when you run the specific system batch job. Then I would like to talk as the last one about plan guides. And I mentioned here, yeah, do not use plan guides as a first mitigation step. And what we mean with this is that we always need to try in a tuning exercise. For example, we discover a certain expensive code, and this code has maybe 1 or 2 or multiple expensive queries behind. What we first should do as a first step is question the code, correct? So maybe we have to use a different pattern. Think about, for example, go set based, or I don't know, could be any change on the code level. If you then drill a little bit deeper into the queries that this code will generate, then maybe these queries need to have additional indexes or change to indexes. Maybe my query, I have to increase the selectivity. I can add some hints also from the code perspective already to the query. Maybe actions like rebuild index or update statistics for the specific table, underlying table will help. So there are different other things I can do before I maybe come to, okay, there is no other choice. I have to somehow guide the SQL or SQL Azure to use the correct resolution plan. I need to create a plan guide. One thing about update statistics, it's not meant separately here. Update statistics is taken care of by us in the backend by doing it. So there is a whole monitoring mechanism in the backend which take care of this update statistics, but still it could be that in certain situations you want to update statistics for a specific table, and this is an action you can also do through LCS. So let's go back to the plan guide. So here I highlight one example, which is also an example you should all be aware of. Could be, for example, the fact that we use parameterized queries. And it could be a solution to use a plan guide to overcome parameter sniffing. And what it is that SQL will recompute a new plan each time the plan guide is flushed. For example, one example could be here when you update of a statistic run is done. So the plan that is chosen then is based on sniffing the parameters at the first execution of the query. And that could be an ideal plan, but maybe also not when the parameters will change. Typically, the example could be a large and a smaller data entity, for example, where the plan could be totally different based on different parameter settings. But of course, if you store the first plan and you would like to have this reused also for the next queries, or you maybe would like to have a different plan to be used for a query with different parameters. So maybe you would like to guide SQL Azure in the backend to use for one specific set of parameters, one specific plan, and for the other set of parameters, you would like to use a different plan. So for this, plan guides could help. And we also made this available on the LCS. So we have actually 2 options there. The first option is create a plan guide to force a plan ID. So the ID is, for example, okay, you have an expensive query, you retrieve different plan IDs, right, for this, and you do an analysis. And based on this, you discover, okay, this is the best plan that actually should be used to resolve this query with this specific set of parameters. You test it, and then in the end, you could create a plan guide directly through LCS, and this will then
force the plan to be used by creating a plan guide. Make sure that, yeah, everything should be exactly the same. There is a query cookbook on the docs, which will specify and detail what you have to fill in each of these different parameters. But even a simple white space or something can make your plan guide not to work correctly. Also to note down that if you create such a plan guide, it's just for that specific database, correct? So if you create it in production, it's only done on the production database. It's important to have, of course, the same changes done as well on your other environments, definitely your test environments, correct? To have a reliable test environment. Of course, this is important to highlight. The other option could be, of course, that you then do a DB refresh from the production back to your UAT to have again the same plan guides on both environments. This is also, again, to remind you that everything is in this change history. So also when you create a plan guide on this environment, for example, today, then you can see that there is a trace of this. So could see when plan guides are created and who created that plan guide, and hopefully what was the reason for creating a plan guide. The last one where you could create a plan guide for is another option that you have in LCS, is for example when you want to add specific table hints. Could be a similar exercise that you do, and then in the end you determine maybe you do not want to force a specific plan. But for example, you see that for one of the tables that you're querying on, it's always doing a scan when your analysis shows and your testing shows it should be a seek as better. So you could, for example, add a force seek hint or table hint to a query. So similar than you did before with forcing a specific plan with a plan ID, you can then force to add a certain table hint and create a plan guide like this through LCS. Again, only for the specific database done on the production or wherever you create it on. And so you have to make aware that all your environments are in sync with every action you do directly on the database backend. So with this, I would like to open for a summary of the Q&A. So Marcus, if you would like to take the word.
Yes, of course. Thank you, David. I hope you can hear me all. So with the Q&A, I want to start from the kind of bottom. There were some questions about how we actually detect if you have a set-based operation and defined in the code, and that's reverted to record-based operations. So there are a couple of things how you could detect this. One of those is collect an AX trace in the pre-production and then analyze with trace parser. Another option could be that you search for expensive queries which are executed quite a lot of times. So if you sort your analysis on expensive queries by the number of how often the queries has been executed in a certain amount of time, then you would detect this kind of situation where in theoretically you have developed a set-based operation, but now this is reverted to record-based operations. And then of course it's a matter of analyzing how you prevent this from happening, or we also have seen cases where that actually kind of helped in terms of performance if it comes to locking blocking, because set-based operations also has a higher footprint on the locking blocking than row by row based operations, but that's really depends on your use case and the situation you run into. But as I said, the best approach would be really to have a repo on a pre-production environment, then trace it, then analyze it. There were a couple of questions about the indexes which has been automatically added by us as a process of the monitoring. You probably know that we have monitoring going on in the background, and this is so-called watchdog. And sometimes it happens that we detect a missing index, which has a larger impact on your environment, and then we, so to speak, silently add those indexes to your production environment to ensure that your processes are still running smoothly. Indexes like this are, they have the VDI, WDI prefix. So if you do a database refresh from production to sandbox, or you have the indexes overview in the LCS monitoring as a query, then you might see indexes like this that has been added to the tables where you didn't expect that. There was a question about benchmarking. You are probably aware that we do not publish any benchmarks anymore from the official perspective. And the idea is really to, within the project, within the implementation project, to have a proper performance testing planned and executed during the implementation project whenever you hit a larger milestone or a change within the project, because the risk with the standard benchmarking, this all is happening with standard code, with no modifications, not with your data, nor with the specific code changes or the partner solutions you also have implemented. So that was the reason why a decision was made not to publish any standard benchmarking anymore, but to rely on a proper performance testing during the implementation. I'm just browsing through the questions backwards. Yeah, so there was a question about I use a certain functionality like DMF staging cleanup, and it doesn't do anything, so it seems not to work. In a situation like this, this is a valid approach to create a support ticket and just let us know, and we will try to do our very best to ensure that the functionality is working again, or at least that the problem is analyzed, and we can help you with this moving forward. There were some other questions about batch threads and the scheduling, and Davey mentioned this as well, that in AX 2012, we sometimes had the approach that we want to isolate the batch workload from the user workload, and the OData interface is also part of the user workload. But this possibility has gone with Dynamics 365 for finance and operations. So now we mix the workload. And then the question was, so how many threads should I attach to a certain server if there is a mixed workload? There is not a clear answer, but as we have more workload now on a specific server, I mean a mixture between batch and user workload, I even would reduce the number of available batch threads on an AOS even further as a starting point. Of course, it really depends on the nature of your batch threads. I mean, if you run an ERP with 80 parallel or with 20 parallel threads on any given server, then you for sure will see a degradation of user responsiveness on that server. So it's really depending on the nature of the batch threads, whether you have to go down with your number of batch threads on the specific server, or you are still okay. In the LCS monitoring part, there is the possibility to look at the processor usage of the AOS, so you can kind of monitor this on the production. Or if you want to deep dive into the other possibilities, then you are kind of forced to do a repro on the pre-production environment and to really ensure that your setup of the batch threads and the schedule of the batch threads is working in your situation, because it really depends on what you are doing parallel to the batch threads. Yeah, so nearly at the beginning. Yeah, there was one question about cleanup procedures, that you shouldn't do the cleanup while the batch, other batch jobs are still executed. I mean, as a probably general advice is any kind of cleanup needs to be scheduled and also kind of monitored during the cleanup. Because if you just kick off a cleanup in the middle of your peak workload, and it really doesn't matter whether it's batch job or any other cleanup, if you have a high workload on the same tables while you try to cleaning it up, that doesn't perform well in parallel. So cleanup in general needs to be scheduled and also monitored. And if there is a kind of problem popping up during the cleanup, then that was the first learning already, to stop the cleanup as of now and move it to a time where you have less activity on the specific tables which you want to clean up. I'm going up to other questions. There was a question about Power Apps and the OData. I mean, it all started with our learning. This OData is, yes, this is an opportunity, but you really shouldn't abuse or overuse the OData interface. And questioned to the Power Apps. So yes, OData is currently the only interface supporting Power Apps. But that then goes back to the design decision for which kind of interfaces or interactions you really want to use this OData. And with not, let's say, overusing or misusing the OData, we really mean for high workload integrations. Because this is something you want to stay off. So basically don't use OData for high workload integrations, because this will for sure not succeed, or will also cause a lot of load to the system, meaning that other users will not have fun on your environment, will not get the expected performance. Yeah, browsing back a bit. I think I went through all the Q&A. Now verbally browsing.
Maybe one thing to add about the OData is that, yeah, because we had so many issues, and I probably forgot to mention, but in one of the next PUs, I think platform update 24, we will limit the number of resources that it can consume on the SQL backend with Resource Governor, just to avoid that it can, yeah, bring a whole SQL to 100% of DTU and yeah, bring the business almost to a standstill.
Yeah, you're probably aware that we do the similar things on batch framework already. So the batch framework is kind of throttled so that we have at least minimum responsiveness for ad hoc workload, and same procedure might be applied for OData in the future. There were some later questions on Watchdog. Yes, with Watchdog we detect things, and sometimes we are tempted to change, either adding an index, I mentioned that already, or changing the log escalation levels on tables. This is sometimes done if in case it helps. But in terms of changing the log escalation level, I mean, if you, I think it's part of the LCS self-service possibilities, right, in the actions area. I'm trying to pause backwards. I think most of the questions has been answered. So.
Okay.
Yeah, unless we have last minute, we still have some questions open. So I guess we still remain in the call to answer the remaining questions, but giving back to Davey.
Okay, thank you, Marcus. And of course, if you have any questions related to this content later on, you can always reach out to